Okay, these are some problems from section 5.5, and these are trig and metric equations. And the first one is sine of x equals the square root of 3 over 2, so we want to find out what x is. And this is for all solutions of each equation, so there's no domain specified, so it could be all real numbers. Usually we restrict our domain from 0 to 2 pi, but now we're going to do all solutions, so it's going to be a little more challenging. So, first of all, we know from our unit circle that the sine of something equals the square root of 3 over 2. Well, we go back, and the sine of what angle is the square root of 3 over 2? And that looks like that's going to be pi over 3, if you recall. Now, the easiest way to check this is put this back in. What's the sine of pi over 3? Square root of 3 over 2. That's why you have to know your unit circle, all right? If this is 1/2, it would be pi over 6, because the sine of 1/2 is pi over 6, okay? But remember, we have to take into all the considerations of the whole natural domain, which is 0 to 2 pi. The period is 0 to 2 pi. That's one whole period. For the sine function, remember that. You can always graph that sine function. There's your 2 pi. Divide that into 4 spots. This is your 1. This is your minus 1. And remember, it starts at the sine of 0, 0. That's all you know. And then you go up 1, down 1, down 1, back up 1. And there's your sine. And this is one whole cycle, or one whole period. There's your y. There's your x. So you know you're going to have pretty numbers, unless they're right here. If the without counting the endpoint here, from 0 to 2 pi, we're going to have two solutions. We'll have one solution there, but we're normally going to have two solutions, even two solutions up to there, or two solutions down there. And these are like our quadrants. This is like the first quadrant, second quadrant, third quadrant, fourth quadrant. When we look at the unit circle, so we also have x can be equal to, well, where's the sign positive? Well, again, you can remember all students take calculus, so we got a lot of little things to help us here. All students take calculus. So we know that the sine of x equals square root of 3 over 2. Well, that's positive. So the sign is positive in the first and in the second quadrant, so we could also have 2 pi over 3. So those are our solutions. Okay, and both these solutions satisfy this equation. The sine of pi over 3 is the square root of 3 over 2, and the sine of 2 pi over 3 is also positive, the square root of 3 over 2. Okay? But we know that this keeps going on and on and on in both directions, so we have to take that into consideration. And we know the period is 2 pi, so we're just going to take 2 pi times n. Okay? And because pi is kind of an irrational number, and n is an integer, and 2 is an integer, they usually write it as 2n pi. But that's fine. 2n pi is the more conventional way to write that. So, and remember, n is an integer. Okay, so they usually say where n is any integer. Okay? And like I say, we usually write it as 2n pi. But hopefully you can, if you see it like this, 2 pi times n, then this tells you that we're just going to be making n 0. Negative 1 means we're going to go in this direction. Negative 2, keep going. Okay? So that covers all the possibilities. Okay? So if that makes sense, so once you understand that, we just kind of follow suit. So number 13. Tangent of x equals 1. Now this is a little different because the tangent basically just has, the period of the tangent is just going to be pi, not 2 pi. And the interesting thing about the tangent is since it's positive in odd coordinates, in other words, it's positive here and here, then once you go 180 degrees, you get another positive angle. So basically, every time you multiply by 180 degrees, you're going to get one of the solutions. This is pi over 2, negative pi over 2, and pi over 2. We put some asymptotes in here. Okay. Then we sketch this tangent. It's going to go like this. It's going to... Okay, then if we look, we're only going to have maybe for any value, we're only going to have maybe one solution, because it is a function single valued, and that's going to repeat itself. So we just have to worry about one solution between negative pi over 2 and pi over 2. One where it's negative, one where it's negative, one where it's positive. So that kind of restricts it, and then we just multiply by n pi rather than 2n pi. And then that's going to get us from this quadrant, if I multiply by pi, this quadrant, that quadrant. So we just have to multiply by n pi. So the tangent is actually a little bit easier. So first of all, the tangent of x equals 1. It's positive 1. So we know that's going to be positive in the first and the third quadrant, but we only have to concern ourselves with the first quadrant. Then we know that x is going to be what? Pi over 4. Because the tangent of pi over 4 is 1. Now we could also say it's going to be also 5 pi over 4. 1, 3, 5, which puts us in this quadrant, 5 pi over 4. But if I add pi to that, that's going to put me into this quadrant anyway. So I just have to say this is the basic function. Then I just keep multiplying by n pi. And that's just going to give me all the solutions. Because when n is 1, I'm just going to add pi to pi over 4. And that's going to put me from this quadrant to that quadrant. Then when n is 2, I go back to that quadrant. n is 3, 4, 5, 6, etc., and even backwards. So that's all you have to worry about for the tangent. Okay, just n pi. Okay, so you don't have to worry about doing two different angles, because the tangent's nice like that, because 180 degrees later we're in another positive quadrant. Or even if it's negative 180 degrees later, we're in another negative quadrant. So that's going to make it a little bit easier to work with. Okay, all right, let's try another one. Now remember, the sine and cosine behave the same. They're a little bit more complicated because they aren't as symmetrical as the tangent is around 0, as far as the way their roots work out. So we have different quadrants. In other words, the sine is positive in adjacent quadrants, and the cosine is positive in adjacent quadrants. So that's why we have to kind of do the two different solutions. Okay, let's take a look at number 15. And this is the cosine of x. And that equals negative 1/2. So our two basic solutions for that, we know the cosine is negative in the second and the third quadrant. So we know that if the cosine of x equals 1/2, that would be basically pi over 3. Okay, but it's negative, so where is it? What quadrants is the cosine negative? It's negative in the second quadrant, so that would be 2 pi over 3. And it's also negative in the, let's write this over here, x can also equal, it's also negative in this quadrant, which would be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. There we go. So those are the two quadrants where it's negative. Cosine is negative, and if I take it and go back and check these, if you take the cosine of 2 pi over 3, you get negative 1/2, 4 pi over 3, negative 1/2, because of the quadrants, second and third quadrant. But we know it's going to be it's going to be periodic, so it's going to keep going, and the period is 2 pi, so we just add 2 pi n, or conventionally 2n pi. And that's just my 2 pi by multiples of n. Okay? And again, we'll just assume that we can just say it once, where n is any integer. Okay? So that's number 15. All right? Okay, so there's 3 right there. Hope those help. And we'll do a few more in a moment. Good luck.